I'm Rachel Levy from the MAA, and I'm so delighted today to introduce our next speaker. Our next speaker is Genetha Gray from Salesforce. Genetha is one of those people in my life who, when I need somebody who can speak to mathematics and industry, who has a real feel for not only what teachers need to understand, what policymakers need to know, and also how it connects to the data, Genetha is always the person that I look to. She helped create the Big Jobs Guide that I was showing you before. She also came to our Critical Issues in Mathematics Education conference on math modeling and stayed the whole time, not only to organize all of our industry panels, but also to hear what people had to say. She worked at Intel as a mathematician and as a data scientist in HR to look at data to understand how to make their hiring and retention practices more equitable. At Salesforce, she's the manager of the data science and research group of the Employee Success Strategy and Analytics team. They focus on understanding and improving something. I hate reading. Oh, she says a nice way to say it is well-being. They focus on understanding and improving employee well-being. It even says it here. Identifying methods that allow dispersed teamwork together and developing skills taxonomy to describe the workforce. In addition, she's responsible for mathematical models and analysis used to execute the equal pay initiatives. So I am so delighted to introduce my friend and colleague, Genetha.
So thank you. And I've learned this at Salesforce. The culture there is that we always thank at the very beginning, because if it wasn't for you, there wouldn't be us. So thank you, Rachel, for that very nice introduction, and thanks to all of you for relaxing after lunch and listening to what I am going to tell you about. So I'm going to start with a little story. And I apologize to the young people in the room. If there's pieces of this you don't understand, later you can ask your older colleagues. So remember Electric Company with the two people and yeah. So I wanted to talk about where did I first start learning about math and how it's viewed. Right after 9/11 and people flew, and that was about the time I finished my PhD, I was traveling a lot, interviews, presenting my work. People were kind of nervous, and they would always sort of check out who was on the plane. And so during that time when you'd sit in the row before taking off, everyone would kind of, so what do you do? Where are you from? Are you legitimate? Basically. And people were always shocked that I studied math. You have a PhD in math? What? And the thing that they would always say is, I can't even balance my checkbook. If you don't recognize this picture, that puts you as a millennial, right? And when they would say this to me, it made me very sad for multiple reasons. The woman from Maine this morning is my cohort in this idea that it's not only okay to say that you're math illiterate, it's the cool thing to say. And that always made me sad. Another thing that made me really sad is that, sure, accounting is cool, but there's so much cool stuff about math. So much. I've had a lot of jobs. I love the job I have now, and there is no way I could have this job if I didn't know math. Yeah, my job is work, and work, the noun means you have to do work the verb, and work the verb is not always fun, so my job is not fun 100% of the time, but in general, I'm incredibly happy, and part of my job is to see that other people are happy at work and doing the things that they want to do. So just to tie it back, now we get on the plane and you can immediately turn on your small devices and put on your headphones and not talk to anyone. And your banking is all done for you electronically. So I don't have this same conversation with people. But I think the overriding theme of what I heard when I started out in my career is still there. And that's sort of this issue we've been talking about all day, that math needs some PR, some positive PR, and that math is super cool. And one of the ways that you can make a change is from the ground up. If you think about the big changes in this country, the acceptance of people of many races and colors, that came from the kids. I think about my son, he's in 1st grade, and he comes home and he just says, "Mommy, isn't it cool so-and-so has 2 moms? How come I don't have 2 moms?" And I say, well, you probably need 2 moms since you have a working mom. You need a traditional mom and a working mom and a dad. But, you know, that's really different than questions I would have asked at that age, because I didn't know any better. So this is a place where it can start, and this is why talking to you about math and what it is and how cool it can be is very exciting to me, because you are talking to the youngest people in this country, and we can change this together. Okay, so why is math cool? Well, in industry, it really is because it allows you to deal with data. And the word deal we'll talk about in a minute. Data's everywhere. There's all kinds of sayings. Data's the new oil. That was the big one when I worked at Intel. That was one of them. Data's everywhere. If you don't know anything about math, you still have data. There's all these people that, what do you mean Facebook is collecting my data? What does that even mean? So data is touching everyone. In industry, it's in every single industry. You'd be shocked at where some mathematicians work now, where they never worked before, and it's because data is there. What I mean by dealing with, I think as a mathematician, the analyze piece is very clear, and the connection there is incredibly clear. You might not have the full breadth, but you can say, all right, but there's all these other pieces. It's got to be collected, stored, protected, retrieved, analyzed, and reported. All of these things. Every single one of these pieces requires that you have math tools under your belt. And every single one of these things is a place where you can get a kid excited about math. So let's talk about collect and retrieve. In my job, we spend a lot of time writing surveys, getting responses, analyzing the data. It's a huge part, these org health surveys. It's giant. So we do a lot of data collection. Kids do a lot of data collection with each other in line. What's your favorite video game? What's this? I mean, I've learned about all these characters I don't know anything about, and they talk to each other and have all these ideas. This is an easy way to start talking about collecting data. But you also need to understand, who do you talk to? This was a huge error made in the United States during the election. The way they collected the data about who they thought would win, they didn't collect it correctly, and they made a wrong assessment. So there's excellent examples of the right and the wrong way to collect data, to look at the representation. Retrieving it is a big thing too. I mean, it's a huge part of my job both at Intel and at Salesforce now, is where is the data stored? How do I get it? Who gets it? Who can get in there and get it? What format is it going in? What format is it coming back to me? How do I validate that what's coming back to me is actually what went in? These are all questions where you can think about the answer with math. These are all questions where you can do something with students to try and help them understand, what does this mean? Store and protect, so this is huge. And we saw the information that we don't, from that we don't have enough people to do the analytics, I think it's even more dire for cybersecurity in terms of protection and who knows about this. There are so many cool math problems there. There are so many cool math modeling problems that you can do. One of my favorite things to do with kids is to give them a Sudoku and see if they can figure out what was originally there or not. And that helps them understand you can just put some pieces in and get back the whole thing, and sometimes you can't, depending on whether or not you follow the rules. This is all based on simple math that kids know how to do, and then they start to understand how can you store some pieces. You can also show blurred images. Can they figure out what it is or not? If I showed them the checkbook, no, they can't because they've never seen a checkbook. But these are big questions that they can start to think about. They don't need to know the actual underlying equations, which I personally think are very cool and you can learn about later. But kids can start to think about these questions. Storage is a big thing. Today it seems like, oh, we can just store anything, it's easy, it's cheap. Do you really want to store everything? Have you ever cleaned out an attic or a garage after someone's lived there 100 years? No. You think you want all these things, you might not. So these are things to think about. Analyzing and reporting. Analyzing, I could talk for hours about this because this is where my true passion lies. This is when I first went to graduate school and thought, you know, this is what I'm doing, I'm analyzing. The equations were based more on physics when I started, and now they're based more on data, but the analysis tools are similar or extended to include data situations. It's fun, it's cool, but it's also about 20% of the job, which if you heard Susie talk about Pick Math, the group that I had this year, at the end of the year, that was one of their questions. So is this what it's like? We're going to spend all this time figuring out what the data is and clean it up and how to use it? Yep, that's it. The cool stuff, once you figure out, it's quick. Thanks to computers, it's very fast. The reporting out is, I can't emphasize enough how important the reporting part is. There's a study, right, where people are more scared of death than public speaking, which I don't really quite understand how that works. Public speaking seems to be, at least you're alive. But kids like my son, all he has to do is write down his answer and turn that in. What happens when, there's all these movies where, oh no, I have to go up to the board and they dread it? This should be something that you just get used to from the start. How do you report out your results? How do you show something in a way that someone can see it? I used to work for somebody that was colorblind, and I knew that, so I knew what colors I could show him results in, and I knew what colors he would see nothing. I know if I report to the sales leader, he wants to see things in the same format that he sees his sales in terms of his hiring and retention. And if I report out to one of the engineering leads, they want to see something totally different. And we start to learn that. And how do you get that message across? And how do you communicate back and forth with people that are not experts in your area but are very smart and experts in their own area, but you need to be able to converse with them in a way where you're not treating them like they're dumb, they're not treating you like you're dumb, but you're both getting your messages to each other. All right, so we've talked about teamwork, and the biggest thing I want to say about teams is this. In industry, you will never be on a team where everyone's an expert in the same thing. Most often, you will be an expert in your area, someone else will be an expert in a different area, someone else will be an expert in a different area. So even the teams that are in classes that are attacking one problem, I think part of the reason that doesn't work is because they're all trying to learn the same thing. So one of the things that I've done is if you set up a team and give each person a different job, in the same way that they would get a different or have a different part of the assignment in the workforce, then they can begin to understand, this is my part, I need to communicate this is my part, and it's not simply split up by expertise, it's not simply split up by you do problem 1 and 2, I do 3 and 4, and from there, it's more split up by this person has an expertise that they're bringing to the table, this person has an expertise, let's pull it all together. These are all incredibly, incredibly important pieces to solve a data science problem. I never, ever am going to be working completely on my own. Even if it's secondary, I'm going to rely on somebody. I'm never going to be making the problem up in my head, oh, this is what I'm interested in. It might make up the problem based on, oh, I saw the sales leader give this talk and he said they're having problems with X, so maybe I should collect this data. For example, one of our things that came up this year is that people don't really understand how promotion process works. So we went back to the data and said, okay, this is kind of how often people have been promoted to this point. It's changing a lot because the company's growing, and then tried to build a model where people could look at it and then start to think about, okay, this is when I should think about I might be promoted. These are the things I should work on. If I haven't been promoted by this point, maybe I should work on looking for a new job. Things like that. So this is really what I wanted to push to you, and I want to give you some time to ask me some questions. So what does improved preparation mean? The biggest one is definitely extend beyond that traditional word problem. You will never see that. Not just that, but if you can swing it, the number one thing that happens is you take someone a result and they say, okay, that's great, but what about? Or I don't like that answer because of this constraint that I forgot to give you. So if you can think about asking students to work on this, and this is what we do in Pick Math, I just threw a huge thing at them and then they had to formulate a problem for me based on that. So think outside of this, a train left a station at 1 p.m. and the other train, that's never going to come to you that cleanly. And then also rethink, what do I mean by answer? What is the answer? The is not the correct term to use in there. What is an answer? What is the answer that works for leader A? What's the answer that works for leader B? Almost all of these are going to be a multi-objective optimization problem, even if it's in your head, even if one of the things is, this is what the leader that makes the final decision always says, so I need to be somewhere on that front. Work with messy problems. I mean, even in a textbook where it's written out, every once in a while you get a page that's missing or an upside down page. I remember it was super cool in college because one of my books, they taped in the thing upside down, so when I was reading it, it looked like I was reading it upside down. It was a really hard math book, so it just made me look extra cool, like, yeah, it wasn't hard enough, now I have to read it upside down. Things are really messy. There's mistakes. A lot of the automated things that happen, there's error. Have students figure out what is wrong with this picture. What's messy? What shouldn't be long? How should I clean this up? What things should I consider? What should I leave out and why? How can I justify it? These are all incredibly important questions to ask. The work in teams that I mentioned, and I should say work in teams where different people have different roles. Not just you're all attacking one problem, but you have to have a lead on that team and maybe assign different people to do different things. This part is collecting the data on the application, this part is analyzing, this part is figuring out a storage plan, whatever. But the team should be multidisciplinary. And make them present their results, written results, oral results, both. Can they stand up in front of a group and say what it is? One of the hardest classes I had in graduate school, we called it torture chamber. I don't know what its real name was. It kind of got lost. Was read someone's work and present it, and the class would just ask you questions about it until you were like, I'm tortured, okay. But it really helped figure out, what do I present? How do I present it? What's my audience? What do I need to say to them that's important? What is not as important, but I just think it's cool? What are the things that don't matter at all? And I think that one of the things we can really do to improve the overall image of math is to tell the stories of math, because this will help hit home for you. You know, my son is 7, and we tell him, oh, mommy is a doctor of math. She helps sick math problems. That's my description, because he knows what a doctor is. He goes to the doctor, and the doctor gives shots, right? But he doesn't know what a doctor of math is. So then we can start, so that's where we're starting, and then later I can tell him about other things. I can show him things about, oh, look at this waterway. Look at this. I used to work on alternative energy. We can drive past the energy farm, and I can say, look, mommy helped figure out how to place those. And that hits home with him, and then he starts to see, oh, okay, that was a sick math problem that mommy helped fix. And then as people get older, you can give them more age-appropriate descriptions and give examples that aren't just, I can balance my checkbook, okay? I can't emphasize the storytelling enough. That's the part that people will take away. And it's the part where you can be like, seriously, the math is so cool. And if they don't get that part of it, they can at least get what you're doing with it, and that you're not just sitting in a room by yourself doing math. They can understand, okay, this is why you think it's cool, even if they don't want to talk about the intricacies of how you distributed your optimization program on multi-threaded machines so that it ran. They don't care that you're excited about that. They care that I use that to solve this very interesting problem. So I just really emphasize telling the stories and giving the examples. And the other thing I can say is about getting a job. If you don't have a story to tell or an example that's clear, that people will understand about why you can work in this field, you're not going to get the job. I really have a hard time with, I love getting young students coming in. They know of like tons of cool stuff, but I really have a hard time when the only example they can give me is the one class project that they did, which was, you know, completely clean and outlined by the teacher. It doesn't tell me anything about whether or not they're going to be able to do the work that we have to do. I like to hear stories about, even just, I went to an REU camp for a week and we worked on this. Or even one day we visited so-and-so plant, and it was so cool how they figured out how to optimize the line so that, you know, as long as, if they can give me something, it's incredibly important to have that in your toolbox when you're interviewing. Yeah, your grades are going to tell me whether or not you have the tools. But what you tell me and what you do on your entrance test for the job are going to tell me whether or not you know how and when to to use those tools. And I think that's the part where when I talk to a woman on a plane that's like, math, I can't balance my checkbook, that's the part where we can make that start to go away. And we can say, all right, but there's all these kids that are like, math, it's really cool. And then even if they don't go into math, even if they go into something else entirely, like half of the people I work with are IO psychologists, they still understand, oh, I can work with the mathematician on that, which I think is as important as making sure we have enough trained mathematicians. We also have other people that are trained that know how to work with mathematicians, and mathematicians know how to work with them too. So that we have then people coming into the workforce that are saying, cool, these are the people we can work together. And it's pretty exciting. And personally, one of the things that I love about my job is what I learn from the other experts. Like when I talk to the psychologist I work with on well-being, and she tells me some of these things, I'm like, whoa, this is fascinating. And I want everyone to have that and not just feel like I must be in the numbers. So I appreciate your time, and I would love to take some questions. I can hear you.
So thank you for that presentation. So one of the things, our educational system is geared towards, most of the educators end up teaching the mathematical tools or mathematics first, and then show the students the problem. You of course explained the philosophy, which I appreciate a lot, is instead of doing here's the mathematics, go solve the problem, here's the problem, find the mathematics to do it. And this goes back to the comment yesterday about faculty professional development. That's much needed because faculty are all not used to this reverse philosophy in education. That's number one. Number two, that I wanted to ask you also about is, the educational system, Institute of Higher Education almost treats students as consumers of education. So we're always giving them something. But in reality, if you accept them to be producers of information, actually peer reviewers, it becomes much more powerful. Of course, you see all this in the industry side. So I would like to hear your comments about how this transformation, this paradigm shift can happen in education.
So I think in industry, and I am a huge proponent of this from both sides, is the number one thing is the internships. From the corporate side, from my side, two things happen. One, let's just put it out there, the ROI is huge, right? Students are so cheap, it's awesome. I can always fit them in my budget. It's great, okay? And it's not so cheap that they're not making any money. In fact, a lot of them are like, whoa, yay, now I don't have to work during I can work just in the summer at this internship and I don't have to work during the school year. So that's great. And the other thing is that they bring a lot of the new research. And that, to me, is something I don't always have as much time for as I'd like, so I rely on the interns to bring, hey, this is what we're learning, this is what we're seeing, this is what we saw at the latest conference, so that's important. From the other side of the students, besides the monetary side, the thing I think that is huge is you can see what are the things I can live with in a job and what are the things I can't. So even if you go to an internship and you hate it, one, you got paid, two, you know what you hated. And what was that? And then make sure that that is not in your long-term job, because then you also have smart questions. So maybe you hated that you weren't in the same place as your manager. Maybe you hated that your manager was in LA and you were in San Francisco and you didn't like that. Then you know, in my next job, my manager and I need to sit in the same building. And that's huge. So I don't think an internship is ever a waste of time, ever. Because learning what you hate is just as important. And some people, it takes them years. Whereas this internship, you're out of it in 12 weeks or 18 weeks. So I think it's incredibly important, and it's a tool that can be used both by the students, also by the professors for things they don't have time for with the problem solving. And then, but it's also incredibly important to industry. It's a huge pipeline for us to hire too, because it's a way for us to see, okay, this person will work out, or okay, this person won't work out, but it wasn't a huge investment. So I think I just can't emphasize enough the importance of internships. And
let's thank our speaker again.
All right, you guys, I'm Katie Arrington. I'm from the Dana Center. I lead the K-12 services work at the Dana Center. I'm gonna pull up my slideshow really quick, but while I'm doing that, let's thank our speaker, both Rachel and Genetha, one more time. All right. Okay, so you just heard a really interesting talk. You've heard a lot of interesting talks today between the few panels that we've had and our speaker just now. So I'm sure there's a lot kind of floating around in your mind. You heard Diane say last night, and David say, I think again this morning, that we're thinking of this forum as a kickoff to the next 18 months or so worth of work. So this forum is fantastic. We're gonna learn a lot together. CBMS has provided this great opportunity and organized this group to get together and really get to work though. So thinking about this complex, multifaceted task that's ahead of us, really digging into the issues that we're all having in all of our states around that kind of junior to junior time period, right? That transition from high school to college. There's a lot of work, it's a lot of thinking, a lot of change to expect. We know that it's gonna take efforts across K-12 and higher ed, and of course we wanna really have workforce involved. So we're thinking about this in a big way, big changes, right? So if we're honest with ourselves, change at scale in any one system is already pretty complicated. And then what we're thinking here is change in a coordinated and aligned way between multiple systems. Everybody take a deep breath. It's gonna be okay, but we know that in order for our students to really have a chance at success, we've gotta start working on this problem, right? We can have greater rates of success if we really dig in and work with this problem together. So you're sitting at tables with your state teams, hopefully. At your team, you probably have people with varied expertise, varied perspectives. You work in different systems, so you work under different governance systems. You work with people who have different habits and different vocabulary than you do, right? So not only is this gonna be a big effort for change, but it's gotta be a big effort to work together to make that change happen. We're gonna have to give some intentional thought to how we work together as a team, as well as how we move forward. So the Dana Center is engaged in this effort to help support you in doing all of that. So do you guys remember the Home Depot slogan, "You can do it, we can help"? This project that you're here to work on, this thought about creating a task force and really making change in your state, it's your work. It's what you're gonna do. But the Dana Center is really here to provide some supports, resources and tools, access to experts, folks who can help you, as well as connecting you guys, right? You guys are gonna be doing the work, so sharing your ideas between each other is gonna be really important. So when you see me come up on stage, that means you're about to do some work. That's a big clue for this forum, at least. So today, your work as teams is to really think together as teams. So you've heard a lot of information this morning. You collected a lot of data before you came here too. And what we want to do is give you the opportunity today to just kind of think about those things as teams, right? Really start processing together, bringing that expertise, those different perspectives to the forefront, and making sure that everybody is working to bring their strengths and come to agreement on the work that you're doing. Tomorrow, we're gonna move into the more putting pen to paper, making things more formalized. We're gonna look at the task force process that I know you guys have all been introduced to, or most of you have been introduced to through a webinar that we had earlier. We're gonna dig in and really start working on the first two objectives in that task force toolkit, in that process. And then we'll make an action plan for immediate and near future next steps. So that gives you a high-level idea of what we're gonna work on together. So in just a few minutes, what I'm gonna ask you guys to do is, if you haven't found it already, I actually see, now that I'm up here, a few people have found it and started making notes already, which is awesome. There's a little reflection guide in the middle of your table. There should be enough for everybody in the room. We may have to pass a couple between tables, though, depending on how many people are at each one. What I'd like you to do is make sure everybody has one of those. And here's what we're gonna do. If I can have your attention for just another second so I can frame this for you. So at the top, you see there's 3 boxes. It says the higher ed group, the K-12 group, and the workforce group. What that is supposed to describe is the people who went to the different breakouts today. So you may be a higher ed person, but if you went to the K-12 session today, you're part of the K-12 group. What I want to make sure is that everybody at your table has a chance to do some reflecting about the takeaways you've had this morning from either the breakouts or from our whole group sessions. I want everybody at the table to share their takeaways, and you guys have a place to jot down some notes if you'd like to. What we want to do, though, is move towards not just what are your takeaways, but really how does that apply in my state? What are the implications that we need to start thinking about as we're thinking about our task force work? What does that actually mean for us? And then, of course, today, in the middle of the first day, you're gonna have a lot of questions. So what we're gonna do is we're gonna give you until, I think we have until 2:30 on the schedule. What we want you to do is just have a good conversation, get to know the people at your table if you don't already, and talk about what you've learned so far, the implications for that, and what questions you still have. So between now and 2:30, you have time to do that together as a group. Let's see, what time is our break on the agenda? 2:30 to 2:45, right? 2:30 to 3 o'clock. Okay, so you have between now and 2:30 to do some processing together. You'll have a little break, and then at 3 o'clock we'll come back together for our last panel of the day, and then some more work towards the end of the day. Anybody have questions on your assignment right now? I do have it electronically. So let me think about the best way to get it to you. This is not something, just to clarify, this is not something you're gonna be asked to turn in or submit. So if you would like it electronically, I'm happy to get it to you, but don't feel like you're gonna need to give it to anyone. This is completely for your benefit. And we'll start back here at 3 o'clock. You guys, if you want to go to other rooms, you're welcome to, but you have a certain time limit, so consider your transition time.